In this question, it is given that z minus alpha upon z plus alpha is purely imaginary number. That means the real part of your function of z is 0. So let's try to simplify by taking z is equal to x plus iy. So in denominator, we'll get x plus iy minus alpha upon x plus iy plus alpha. Basically, your alpha is a real number. So we should consider x as well as minus alpha as a real part of the complex number. And iy will be imaginary part. So in denominator, we'll get x plus alpha plus iy. For further simplification, we have to multiply and divide by conjugate of the denominator, which is x plus alpha minus iy. So let's multiply and divide by it. Now, x minus alpha into x plus alpha will give us x square minus alpha square, and x minus alpha into minus iy will be minus xyi plus alpha yi. Now we have to multiply iy with x plus alpha will give us xyi plus alpha yi, and iy into minus iy will be minus I square y square upon, in denominator we have a plus b into a minus b form, which will become a square minus b square, or we can say x plus alpha the whole square minus iy the whole square. So x minus alpha square and your I square will be minus 1. So x square minus alpha square minus y square will be your real part, and minus xyi plus xyi will cancel out. We will get 2 times alpha yi as an imaginary part. Let's give individual denominator. So we get the standard form of complex function. Now it is given that the real part of the complex number is 0. So here we get x square minus alpha square plus y square is equal to 0, which will give us x square plus y square is equal to alpha square, or we can say alpha is under root of x square plus y square, which is nothing but mod z, and it is given that the magnitude of z is 2, which is also the answer of alpha. So option A is your answer. Ta-da! In this question, we have set is alpha plus I upon alpha minus I, where alpha is a real number. So we have to find the shape of this set. So let's try to simplify. And for that, we have to multiply and divide of conjugate of the denominator, which is alpha plus I. So in denominator, we'll get alpha plus I the whole square, which can be expanded as alpha square plus 2 alpha I plus I square. And in denominator, we'll get alpha square minus I square. So here we'll get alpha square, and this I square will become minus 1 plus 2 alpha I, and your denominator will be alpha square plus 1. So let's give individual denominator. If we consider x plus iy as a standard form, mod on both sides and squaring the both sides. So we'll get x square plus y square is equal to the whole square of real part, which is alpha square minus 1 upon alpha square plus 1 plus square of imaginary part, which is 2 alpha upon alpha square plus 1. So here we'll get alpha square plus 1 the whole square. Let's expand your alpha square minus 1 the whole square, which will be alpha raised to 4 minus 2 alpha square plus 1 plus 2 alpha square will be 4 alpha square, or we can say this minus 2 alpha square and plus 4 alpha square will become 2 alpha square. So in denominator, we'll get alpha square plus 1 the whole square, and your denominator will be as it is. So finally, we will get x square plus y square is equal to 1. So this is the equation of circle whose radius is 1. Option B is your answer. Ta-da! In this question, it is given that a is a positive number and complex number z is equal to 1 plus I the whole square upon a minus I. Then we have to find conjugate of complex number z. Now, first of all, let's simplify your z. Let's expand your denominator, which will be 1 plus 2y plus I square. And denominator will be as it is. And we know that your I square is nothing but minus 1. So 1 and minus 1 will cancel out. We'll get 2y upon a minus I. So for further simplification, we have to multiply and divide the conjugate of the denominator, which is a plus I. So 2y multiply with a will give us 2ai, and 2i multiply with I will give us 2i square. And in denominator, we'll get a square minus I square. So we can say your z will be minus 2 plus 2ai upon a square plus 1. Now, it is also given that its magnitude is root 2 by 5. So let's try to find out its magnitude. So here we'll get my magnitude of minus 2 plus 2ai upon magnitude of a square plus 1, and take square on both sides. Magnitude of z square will be 2 by 5. Magnitude of minus 2 plus 2i, the whole square will be real part square plus imaginary part square, and a square plus 1 the whole square will be a raised to 4 plus 2a square plus 1. Now let's cross multiply. So we'll get 2 times a raised to 4 plus 4a square plus 1 is equal to 20 plus 20a square. Okay. So 2a raised to 4 will be as it is. This 4a square minus 20a square will be minus 60a square. So this 2 minus 20 will be minus 18. Now we can put 2 common. So we'll get a raised to 4 minus 8a square minus 9 is equal to 0. Now just factorize. So factors person, we will get a square minus 9 and a square plus 1 is equal to 0. So we will get a square is equal to 9 will lead us a is equal to plus or minus 3, and a square is equal to minus 1, which is not possible because a is greater than 0. So the only answer we will get will be a equal to 3, which is greater than 0. Now don't forget, we have to find out conjugate of complex number z. So let's get simplified complex number z and substitute the value of a is equal to 3. So we will get z is equal to minus 2 plus 6i upon a square plus 1, or we can say 10. So your complex number is minus 1 by 5 plus 3 by 5 I. But don't forget, we have to find out conjugate of this complex number, which will be minus 1 by 5 and minus 3 by 5 I, which is given in option 1. Ta-da! Here we have one equation, mod z minus I is equal to mod z minus 1, represent with curve. Now, to get the well-known form of the curve, we just have to substitute z is equal to x plus iy. So here we'll get x plus iy minus I is equal to mod x plus iy minus 1. Here on left hand side, x is the real part, and if we take I common, we'll get y minus 1 as the imaginary part. Similarly, on right hand side, x minus 1 will be your real part and y will be your imaginary part. Now, take a square on both sides and find out magnitude. We'll get real part square plus imaginary part square is equal to x minus 1 the whole square plus y square. Now, for further simplification, you have to expand the bracket. So you'll get y square minus 2y plus 1. Similarly, on right hand side, we'll get x square minus 2x plus 1 plus y square. X square, y square, and plus 1 will be cancelled out. We will get simply y is equal to x, which is the equation of straight line, which is passing from origin and having slope is equal to 1, given in option B. Ta-da! Here we have one complex number z with imaginary part is equal to 10. So your complex number will be x plus 10i, which satisfied 2 upon z minus n upon 2z 2z minus n upon 2z plus n is equal to 2i minus 1. So let's substitute the value of z in given condition. So we'll get 2 times x plus 10i minus n upon 2 times x plus 10i plus n is equal to 2y minus 1. So we have to find real part as well as value of n. So let's try to simplify. So your numerator will be 2x plus 20i minus n, which is your real part. So take it with the real part. And this denominator should be moved to the right hand side. So we have to multiply minus 1 plus 2y with 2x plus 20i plus n. Multiply minus 1 with the bracket will give us minus 2x minus n minus 20i, and minus 2i will give us minus 4xi plus 2ni plus 40i square. Now we know that your I square is minus 1. So we'll get minus 2x minus n and minus 40. If we take I common, we'll get minus 20 minus 4x plus 2n as your imaginary part. So compare with the left hand side. From real part, we will get this 2x minus n, which is the real part of the left hand side, is equal to real part of right hand side. So minus n will cancel out and we will get 4x is equal to minus 40, or we will get x is equal to minus 10. Now, from imaginary part, we will get 20 is equal to, so 2n is equal to 40 minus 4x, where your x is minus 10. So we'll get n is equal to 40, which is given in option C. Ta-da! Your complex number z is combination of two complex numbers. We have to simplify and get the real part as well as imaginary part. So first of all, let's try to simplify our first complex number. Let's say it is z1. Real part is root 3 by 2 and imaginary part is 1 by 2. To get z1 raised to 5, we have to convert this in terms of polar form. And for that, we need its modulus, which is under root of real part square plus imaginary part square 1, and its argument. Your real part as well as imaginary part is in first quadrant, so we just have to find out tan inverse of b by, or we can say 1 by 2 upon root 3 by 2 will be pi by 6. Similarly, Let's try to simplify a second complex number z2 having real part root 3 by 2 and imaginary part minus 1 by 2. So its modulus will be under root of 3 by 4 plus 1 by 4, or we can say 1. Its argument will be x positive, y negative, means its argument is lies in third quadrant. So be minus tan inverse of b by 1 by 2 upon root 3 by 2. So that will be minus pi by 6. So we can convert your z1 in terms of polar form, which is r1 e raised to I theta 1, or we can say 1 e raised to pi by 6i. Similarly, your z2 will be 1 e raised to minus pi by 6i. Now, we have to find out complex number z, which is equal to z1 raised to 5 plus z2 raised to 5. So here we'll get whole raised to 5 of e raised to pi by 6i plus whole raised to 5 of e raised to minus pi by 6i. So here we get e raised to pi by 6i plus e raised to minus pi by 6i. Now let's convert into the polar form. So we'll get cos 5 pi by 6 plus I sin 5 by pi by 6. Similarly, your second term will be expanded as cos minus 5 pi by 6 plus I sin minus 5 pi by 6. And we know that cos is an even function. So that will be cos 5 pi by 6 and sin will be minus sin 5 pi by 6. So your imaginary part will be cancelled out and your complex number will become 2 times cos 5 pi by 6. So here correct option is option A, where imaginary part is 0. Ta-da! In this question, we have z is equal to root 3 by 2 plus I by 2. Or we can say root 3 plus I by 2. Unity of cube root of unity આવું કરીને એક ટોપિક શીખવાડ્યો હતો. Z is equal to 1 raised to 1 by 3. અને એવું કીધું હતું કે Z1 is equal to 1 હોય, Z2 is equal to Z1, Z2 નહીં, Z2 માટે આપણે ઓમેગા વર્ડ યુઝ કર્યો હતો. -1 plus root 3i by 2 and Z2, which is omega square, will be -1 minus root 3i by 2. तो आ एक भी ओमेगा बना था, ओमेगा का ओमेगा स्क्वायर, ठीक है, ऐसा नहीं बनतो. But if we multiply I on both sides, we'll get root 3i plus I square by 2. Or we can say Iz is equal to -1 plus root 3i by 2, which is nothing but omega. So your Z is nothing but minus I omega. Now we have to find out 1 plus Iz plus Z raised to 5 plus Iz raised to 8 whole raised to 9. ચલો હવે એક નાનકડી બીજી વસ્તુ યાદ કરાવી દઉં. I raised to 18 કેવી રીતે શોધતા હતા? એટલે 18 divided by 4 કરતા હતા. 4 4s are 16 અને 2. તો I raised to 4 નો 4 power અને remaining power જે હતો એ 2. This will become your 1 and I square will become minus. આ રીતે શોધતા હતા. યાદ આવી ગયું? એ જ રીતે ઓમેગા રેસ ટુ 38 શોધવું હોય ને તો 38 divided by 3 કરવાનું. 3 1s are 3, 3 2s are 6, remaining power is 2. So this will be omega cube raised to 12 and omega square. આ જે remainder હોય ને એ અહીંયા જાય. And omega cube is 1, so we don't have to worry about it. Omega raised to 30 is simply omega square. Okay? તમે કહેશો સર આ બધું કેમ ભણાવવા મળે? કે એની જરૂર છે એટલે જો we have to find out z raised to 5. So z raised to 5 is nothing but -1 raised to 5, I raised to 5 and omega raised to 5. -1 raised to 5 will be -1. I raised to 5 will be I, and omega raised to 5 will be omega square. So this will be minus I omega square. Similarly, let's try to find out z raised to 8 minus 1 raised to 8, I raised to 8, and omega raised to 8. Minus 1 raised to 8 will be 1, I raised to is also 1, and omega raised to 8 will be omega square. So we are ready to find out 1 plus iz plus z raised to 5 and iz raised to 8 whole raised to 9. Your 1, and instead of z, we have to place minus I omega. Your z raised to 5 is minus I omega square, and your z raised to 8 is nothing but omega square. Now let's simplify. Here we get, in second term, we'll get minus I square omega. Minus I omega square plus I omega square will be cancelled out, and your I square is nothing but minus 1. So we'll get 1 plus omega. હવે 1 plus omega raised to 9 કરવું બી અઘરું પડે. So 1 plus omega can be rewrite as minus omega square. So here we get minus omega square raised to 9, or we can say minus omega raised to 18. હવે omega raised to 18 find કરતા તો તમને આવડે. We just have to divide 18 by 3, or we can say omega cube raised to 6. Omega cube is 1, so your final answer will be minus 1, which is given in option 4. Ta-da!